A fire started in Forestdale at midnight on 2nd of February 2014. Strong easterly winds sent the fire west into the city of Coburn. 498 hectares were impacted. The fire ended up burning all 7 of our Shirley Balla quadrats. Shirley Balla is outlined in green up there, and the stars are our quadrats. These 7 quadrats had been set up, along with 24 others, to monitor the effects of spraying one of the major Banksia woodland weeds, perennial Veldt grass, across 5 bushland areas. The quadrats for the perennial Veldt monitoring are at Harrisdale Swamp, Rose Shanks, Shirley Balla, Cogalup and the Spectacles. The quadrats had had 1 year of herbicide control before the fire. It was a very hot summer wildfire. This is a photo 9 days after the fire. The fire provided an opportunity to study in a local Perth Banksia woodland for a hot summer fire, the recovery of understorey species, changes to diversity, abundance and cover, tree recovery strategies and tree mortality, vegetation recovery and different ways of measuring that, and impacts of weed control. We put together a post-fire monitoring program, visiting Shirley Balla monthly for 6 months, then quarterly for 15 months, then biannually since then. Our survey methods included traditional 10 by 10 metre quadrats for count and cover of perennial plants, 1 by 1 metre quadrats for count and cover of annual plants and seedlings, 25 by 25 metre tree quadrats, and photo monitoring, methods that we had already established in our permanent Banksia Woodland and Restoration monitoring sites. You'll note I'll keep making references to the similarities between the bush recovering after fire and the new bushland we're establishing at our restoration sites. Our staff in the Banksia Woodland Restoration team work closely on both projects. What we observed first after the fire was that for several months, vigorously resprouting perennial natives dominated the recovering bush. As early as 24 days post-fire, some natives were resprouting. Unfortunately, perennial Veldt was also observed resprouting by early April, only 2 months after the fire. We're still monitoring the recovery of common Banksia woodland resprouting species, as you can see here. Once the winter rains began, seedlings started appearing, lots of seedlings. In some cases, there were 86 Herbertia seedlings in just one metre square quadrat. A lot of these disturbance-loving species, reseeding after fire at Shirley Balla, were the same ones that germinated in abundance in our restoration sites after topsoil from Jandakot Airport was spread. Unfortunately, not just native seedlings germinated. By August, most weed seedlings had also germinated, including Veldt. The ash from burnt vegetation provided a valuable source of nutrients to both natives and weeds. You should have seen the size of the Trachomenes that are normally little herbs. They were small shrubs. The ash bed enhances germination, resprouting and seed production, including for any Veldt seeds that haven't been burnt in the top layer of the soil. Some species responded by both resprouting and reseeding. This was observed in a couple of species that traditionally are thought of as being seeders, not resprouters. The recovery of species we recorded is here shown graphically by a regeneration method. The stacked area graph shows the species richness over time of native plants which germinated from seeds or resprouted from roots, tubers, rhizomes, stems or bases. Reseeding plants became almost as diverse during the first winter after the fire as the resprouting species. This research into understanding which species return by resprouting or reseeding is useful to inform restoration management to determine which species to expect to come from topsoil and which species should be returned by planting. or direct seeding. Plant cover is shown here before the fire. After the fire, plant cover is steadily increasing. We're continuing to collect data, and we'll update these graphs after our next survey in spring this year. We were fortunate to have diversity, count and cover data for the 7 quadrats from before the fire. The total number of species has changed after the fire, 122 species before and 160 species after. 110 natives were present in the quadrats before the fire. 4 of the natives never reappeared after the fire. Well, they haven't so far. There were 12 weeds in the quadrats before the fire, and 1 of the weeds hasn't returned after the fire. After the fire, 119 natives have been recorded in the quadrats, including 13 native species that are new to the quadrats. These are often the shorter-lived disturbance or fire-responsive species. These again are the species that have also done well at our restoration sites. But the real big winners from the fire are the 30 new weeds that have been recorded in the quadrats after the fire. Before we move on, it's worthwhile to note that the natives that were there before and after the fire are not necessarily re-establishing in the same proportions after the fire as before the fire. We're seeing the native Banksia glabrescens being a big winner at Shirley Balla after the fire. Before the fire, there was hardly any Banksia, then we had the fire, and by now there's nothing but Banksia. This species can also take over at our restoration site, and we generally don't like to plant it there. Drosera erythorrhiza was the first species to flower after the fire by early June. We recorded time to first observation of the species after the fire, first flowering and the first seeding for all natives and weeds. And the graph shows the cumulative number of just the native flowering and seeding species by month post-fire. Grass trees flowered and produced copious seed post-fire. Nuytsias, or Christmas trees, started flowering magnificently and early. Here are Nuytsia trees heavily laden with flowers and seeds. Grass trees and Christmas trees were the top 2 seeders at Shirley Balla after the fire. Here are seeds of Nuytsia, or Christmas trees, and seeds of the fire ephemeral Ostrostipa compressor. They're the ones, there's the old seed heads of the Ostrostipa, and the seeds have got the little curved awns. Not only do Ostrostipa seeds tolerate high heat better than seeds of the other common grass at Shirley Balla, that's Veldt, they also bury themselves 4 centimetres under the soil, facilitated by their hygroscopic awns that drill their way 4 centimetres into the soil, ensuring yet further protection from the next bushfire, resulting in these wonderful fields of native grasses, as we saw at Shirley Balla the first spring after the fire. No Banksias were observed to be resprouting at Shirley Balla by 24 days post-fire, but by 44 days, all upland Banksia species were resprouting from either the base, the trunk, or the canopy, or combinations of these. We used 25 by 25 metre quadrats 6 months and 18 months after the fire to measure Banksia recovery. We recorded resprouting location and diameter of each of the 3 Banksias. 13% of all Banksias we found resprouted from the base, 23% from the trunk, and 25% from the canopy. And unfortunately, 33% of Banksia trees died in the fire, and 6% died the summer after the fire, after they had resprouted initially. So looking for now just at the Banksias in the graph, although it's the same pattern for all trees. Larger trees, that is older, greater than 20 centimetres in diameter, survived the fire better. They were also the ones that resprouted in the canopy. That data's not shown here. And smaller trees died. Just how long it takes for Banksias to have trunks 20 centimetres in diameter is the next question, and we're conducting further studies examining Banksia growth rates at our Ankertel Road restoration site in collaboration with students at UWA. Banksias not only resprouted after the fire, they also regenerated from seed. Before the fire, we recorded Banksia seed germination to be about 250 seedlings per hectare. Then in the first winter after the fire, germination was an average of 20 times the pre-fire rate at about 6,000 seedlings per hectare. Over the first summer, 70% of them survived to then become yearlings. In the second winter after the fire, Banksia germination was again low, back at pre-fire levels, and subsequently, again in the second summer, there were losses. And the status by spring 2015, the result is that just over 50% of seedlings that germinated after the fire are surviving. And as Anna mentioned, Banksia menziesii trees, the same is happening at Shirley Balla as at the restoration sites. At 3 years old, they're flowering for the first time. So this is a tree that was a young tree that germinated after the fire. One way of observing the recovery of vegetation after fire is by photo monitoring the 10 by 10 metre quadrats. The quadrat photographed here was one that was sprayed for Veldt. So you can see before the fire and before any Veldt control was done, lots of Veldt. After the fire, increasing cover of vegetation and native vegetation and very little Veldt. If you're interested, the Northern Agricultural Catchments Council hosts a website on which you can store and view photo monitoring photos. They've also developed a smartphone app which community members have used to photograph restoration or rehab sites using guide photos to enable correct superimposition of subsequent photos on exactly the same spot. And we've uploaded over 300 photos from Shirley Balla which show vegetation recovery over time that anyone can see on the web. Other ways we've used to estimate recovery of vegetation at Shirley Balla after the fire involves estimating cover in the 9 1 by 1 metre quadrats from each 10 by 10 metre quadrat, either by visual estimation or by automatic estimation from photographs using computer algorithms developed by our remote sensing and spatial analysis section. These 4 photos are from the same quadrat at different times before the fire, and you can see Veldt, which by several months after that one, and the Veldt control has been done. The Veldt's died after the fire and more recently, and very little Veldt, if any. Don't think there's any there, but there's still a long way to go before the quadrats got a lot more native cover in there. Results from the algorithm estimate method show the rate of increase of vegetation cover is calculated to be 1.43% per month. So by the end of the first 19 months after the fire, a total of 27% of the original cover has returned. The same can be done with upward photos of the canopy, resulting in canopy cover shown to be increasing at a much slower pace than the understory at 0.27% per month. Very briefly, spraying to control perennial Veldt grass before the fire led to a substantial reduction in the cover and density of this grass compared to in unsprayed areas. After the fire, the sprayed areas were mostly free of Veldt. Unsprayed areas, however, the fire appeared to increase the Veldt's cover and density. Inconsistent spraying over the next couple of years meant Veldt again took a strong hold after the fire, but it has been sprayed since then, and it will be sprayed again this year. It's important to remember that the results I've presented are from just one site, and it was a very hot fire. The results may not represent all Banksia woodland sites and fires. Bushfires are as diverse as the environments in which they occur. Nevertheless, the fire at Shirley Balla provided the ideal opportunity to study fire, since we had comprehensive pre-fire data, only just having completed surveys a few months before the fire. It also provided the ideal opportunity to trial and compare a range of manual and automated methods of measuring vegetation cover, the results of which have been submitted for publication. We observed and measured the rates of usage of different strategies plants have developed to recover from fire. We've observed there are winners and losers, and that the bush that has resulted has a different floristic composition to that before the fire. We found larger Banksia trees are more resilient than smaller trees, but further studies are required, for example, studies to determine how long it will take for the trees to recover their full reproductive potential. And a special thanks to our volunteers who've helped with the Shirley Balla post-fire monitoring project.